Now let's do this. Draw. Okay. So now what do you do? Y is equal to
1.
Coefficient of x in the numerator and coefficient of x in the denominator.
Yeah.
Okay, now to find out, that's your vertical asymptote. No, horizontal asymptote. Y is equal to 1 is your horizontal asymptote. Y is equal to something is your horizontal asymptote. No?
Yeah.
Correct?
That makes sense.
To write down the vertical asymptote, you make the denominator equal to 0.
Right.
So x square minus 9 is equal to 0. Now there are two ways of doing it. You can factorize it. This is your x minus 3. X plus 3 is equal to 0.
Oh, I'm so silly.
So x is equal to 3 or x is equal to minus 3.
I wasn't saying the minus 3.
So because there are two asymptotes, you'll miss out one totally.
Okay, so the way to I just have to factor.
So root of 9, you can also say root of 9 is plus or minus 3. When your x square is equal to 9, suppose you do it this way, no? X square is equal to 9, suppose you do it this way. Plus or minus root 9. So x is equal to plus or minus 3.
I don't know what I was doing.
Yeah.
I kept on saying 3.
Yeah, that's what. So x is equal to plus 3 or minus 3 or x is equal to plus 3.
Right.
Okay. Now what do you do?
Now new and improved rule.
Now graph the function using GDC.
Yeah.
What's missing? Y. Have a look at that. Look at the graph. You'll find it's going through the asymptote.
Yeah.
You'll see that it's going through the asymptote and it's having only one asymptote.
Right.
The reason for this is the following: new and improved rules for finding the vertical asymptote. What you need to first do is you need to factorize and cancel off terms. Can you factorize the numerator?
Yes.
What is it?
Minus 5. X is minus 5.
Numerator, how 5 comes in? Find the factors, the product should be 12 and the sum should be 7.
Sorry. 3 and 4.
3 and 4.
X minus 3.
X minus 4 and x minus 3.
3. Yeah.
Correct? Denominator, we already factorized x plus 3.
X minus 3.
So your x minus 3 cancels out.
That's why. Okay.
That's why your function now becomes.
And should I plug that in?
Now what's your vertical asymptote? So x plus 3 is equal to 0.
Yeah.
So x is equal to minus 3. So now you'll see only x is equal to minus 3 is the vertical asymptote.
Okay.
Your horizontal asymptote is y is equal to 1. That's fine.
Right.
So what's going to happen is, now listen to this. You will have your vertical asymptote. Correct? At x is equal to minus 3.
Yeah.
You will have your horizontal asymptote at y is equal to 1.
Yeah.
Correct? And you have your graph. You'll have your graph here and one part would be here.
Yeah.
Correct? But because you've cancelled x minus 3, there'd be a hole in the graph at x is equal to 3. That you can't see on your calculator. You need a mathematical brain to see this.
A hole? Just a hole?
There's a hole.
Why is there a hole? Just
because it's not defined at that point. So when x is equal to 3, the function is not defined. How can you verify this? On your calculator you can solve. So you won't be see the hole on the calculator, but if you use your calculator menu, correct, trace 5, yeah, graph trace, and you just type in the number, directly type in 3.
3 equal.
Directly type in 3, so it will show 3 undefined.
So if I get this question on a summative,
they'll ask you where's the hole.
Yeah.
Okay. So first thing is, whenever you see a rational function like this, the first thing is you to think whether you can factorize the numerator or denominator.
Okay.
Factorize, cancel off the terms, and whichever you cancel off, there's a hole at that point.
Yeah.
And then you put your vertical and horizontal asymptote, and then you respect the hole.
Respectable. So if I need to draw this graph, let's say it's like draw this graph.
So you draw the hole like this.
You circle it.
Just circle. Then that shows the hole. It's understood. But you won't be able to see that hole in the calculator. Okay. So don't try to see it. There's nothing wrong with the calculator.
Okay, I was like, what? I was so confused.
Okay, fine. So there's a discontinuity here.
Okay, alright.
So
that's what discontinuity is.
Yeah.
Okay.
So discontinuity means a function is said to be continuous. We can sketch it without lifting your hand off the paper.
Okay.
Like a parabola. Quadratic. A quadratic is what? Can you draw quadratic without lifting the pen of the paper? Can you draw parabola?
Yeah.
Yeah. You can draw parabola without lifting the pen of the paper.
Yes.
So that's a continuous function. Can you draw a rational function without lifting the pen of the paper?
Probably not.
Why not? Because there's a asymptote, na?
Yeah.
There's an asymptote. So quadratic you can draw. Correct?
Yeah.
But when you have a rational function, you have a vertical asymptote.
So you have to stop and then continue.
Yeah. You have to stop at one place, like if this you stop. Now you can't draw this part here. You have to take it off.
Right. Yeah.
So infinite discontinuity, feature of the graph, it has a vertical asymptote. Correct? Like infinite discontinuity. This graph is going to infinity.
Yeah.
And because of that, there's a discontinuity.
Discontinuity as an asymptote. Yeah. Okay.
Because of the asymptote, we are having the discontinuity.
Okay.
Diagram is this. You can have any graph like this. You can also have graph like this, 1 upon x squared.
Yeah. Because that also.
That also is infinite.
These are just terms, random terms. Yeah.
Point discontinuity is what we saw.
When
hole.
they cancel out.
Feature of the graph, there's a hole.
Oh, yeah.
So diagram is, you can have any graph. You can also even have a straight line with a hole.
Yeah.
You can have any graph with a hole. That's your point. At that point, it's not there.
Yeah.
Everywhere else there.
Yeah. And you see that by cancelling it out.
Jump discontinuity is when you have a graph here and there's a jump, the graph continues above. It can be anything. It may not be, it can be a curve also. When there's a jump discontinuity.
Yeah.
This is a jump discontinuity.
Yeah.
So that's a diagram for jump discontinuity.
Yeah. Okay.
Now we are ready to analyze and graph a few rational functions. Step 1. Factor the numerator and denominator of rational functions. Like the last sum we did. You factorize the numerator, factorize the denominator. Write the function in the lowest term after cancelling if possible. So your x minus 3 cancels out.
Right.
You remember?
Right.
Find the domain of the function.
Okay.
So there's a hole in that point. Whichever term cancels out, that's a hole. So that will give you the domain.
That like a vertical asymptote, like that.
Identify the holes in the graph anyway. You know what a holes in the whichever term cancels out, that's a hole. Find out the x-intercept, y-intercept.
Right. X-intercept, you just equate the numerator.
Substitute y to 0.
Oh, right, yeah.
So the numerator will be 0 because when you cross multiply.
Right.
And the y-intercept, put x as 0.
X is 0. Okay. For the numerator.
Yeah. No, overall.
Everything.
Wherever you see x, put that as 0.
Yeah, okay. So it becomes 2.
Determine the horizontal and vertical asymptotes, if any. So to find out the vertical asymptote, denominator equals
to 0. So
and horizontal asymptote
2 and minus.
Yeah. Okay.
This time I'm not making that mistake.
Yeah. Use your graph to graph the function and behavior. Use GDC to graph the function.
Nice.
Find the coordinates of the relative maxima or minima, if there are any. Find the coordinates of 1 or 2 points on each branch of the graph. So just point them, just find them. You are using GDC, they are saying.
Yeah.
Okay. Use your results to graph the rational function by hand.
Wow, lots of steps.
No, it's easy.
Yeah, it's easy. It's just they really made it.
It's just written there for you feel like.
Yeah. Okay.
So what is the first step you should do?
First, I have to factor this. So
correct.
minus 4 and minus 1. Should I?
Yeah. So 2x squared.
Yeah.
Minus 5x plus 2. So 2 ones are 4 ones are.
Yeah. Minus 4x minus x.
So 2x, x minus 2, minus 1, x minus 2. So x minus 2, 2x minus 1.
How do you factor? Do you multiply the 2 by 2?
Yes, we did that, huh?
Yeah.
You multiply 2 by 2.
I'm just asking generally, like, that's how you do it, right?
Yeah, you have to do
that's
it.
That's the best way.
Yeah. You have to.
No, because some of my friends, they do some weird ways.
No need to do it this way.
There's some like
no,
crossing thing. I don't know.
No need of doing that.
Yeah, no, I'm good at factoring out.
Yeah. How do you factorize x squared minus 4?
This time, x minus 2, x plus 2.
Correct. So therefore, what is my function now?
So you're...
So x minus 2.
Yeah, x
2x minus 1 is in the numerator.
X.
Correct. And
x minus 2. Yeah.
So this cancels out?
Yeah, x minus 2.
So hole at
x2. Y is equal to, sorry, x is equal to 2. Yeah.
and hole at x is equal to 2. Correct. Now you get your vertical asymptote.
So that's horizontal is 1, and we already calculated x minus 2 and x plus 2.
X plus 2, make the denominator equal to 0.
Yeah.
So x is equal to minus 2. That's your vertical asymptote.
Right. Oh, because we just cancelled out the minus 2, so it's gone. Okay.
Horizontal asymptote
1.
Y is equal to
2 upon 1. So
2 upon 1. Y is equal to 2.
Yeah.
That correct?
Yes.
Now you get the x-intercept, y-intercept. How do you find out the x-intercept?
You plug in, you make everything equal to 0.
How do you find the x-intercept? You substitute y is equal to 0.
Yeah, y is equal to 0. So
0
is
is
equal to, yeah.
2x minus 1. Of this graph. Don't take this because this
is now we've
now
cancelled
this is modified to this now.
Okay.
So you look, because we are putting the whole now.
Right, yes.
So x is equal to half.
And you don't do anything with the denominator.
Because it will cross multiply now.
Yeah.
Even if you write 2x minus 1 upon x plus 2, you cross multiply. 0 into x plus 2 will be 0.
That's what. Okay.
Even if you don't know how. Now, how do you find out the y-intercept?
It would be 2 upon minus, you just plug in 0 as x. So it would be 2 upon minus 4.
So 2 into 0, correct? Minus 1 upon 0 plus 2.
Why minus 1?
You know, 2 into 0.
Oh, sorry, I keep on looking at the top.
The first cancelled it.
Yeah.
So you do that. With the pencil, you just cancel it.
Okay, done. So you just don't, you look at if there's a hole, you don't look at the original function, you look at the new function. Okay, I'll remember that.
So y is equal to what?
Y is equal to minus 1 upon 2.
So 0 comma minus half.
Yeah. Okay, very cool.
Now, what are they saying? Use your GDC, sketch this graph and take any 2 points.
Okay.
So let's first put this much. So what do we have? Let's start vertical asymptote
at x is equal to minus 2.
Now the graph is going to be very bad and very tiny because the values are very close.
Yeah.
It's minus 2, 4, na?
Yeah.
So we got the vertical asymptote. Horizontal asymptote
2. Should I plug in to the calculator?
Wait, after this.
Okay.
Half 0.
Yes.
So half is somewhere here.
Then minus half.
Minus half.
0
minus half is here. Correct?
Yeah.
Now take any 2 points. Now sketch this graph.
Yeah.
Acha, hole. Sorry, we forgot to put the hole.
Oh, at minus 2.
At x, that is when you're doing that. There's a hole at x is equal to 2.
So just remember.
So first graph this half. First graph 2x minus 1 upon x.
Oh, so instead of graphing the original function.
Even if you graph the original function on this, the calculator look the same.
Okay, so 2. Okay, yeah, that's very cool.
Only that whole you won't get that value.
2x minus 1 divided by
X plus 2.
X plus 2.
Now they're saying you have to take any other 2 points. They said no. Take any other 2 points. So suppose you take x as 6.
So how do is analyze the best
Trace. Trace
same thing. So 5.
5. Okay. 5 doesn't matter. 5. Don't worry. So what is it?
1.29.
5 and 1.29. So
trace graphing is very good.
Yeah.
I like it.
Or else if it's without calculator, then you have to do it manually.
Yeah. How would I? Oh, this I can do manually.
5 2s are 10 minus 1. You have to do it manually. But if you have a calculator, because the thing on top says 5 and 1.29. So you're.
How would I do this though? Because that'd be 10, 9, and then upon 7. 9 upon 7.
Then you have to manually divide. Like that.
Okay.
But this is. Now take one on this half. So take minus 5 or minus 4 or minus 6. Anything else. Directly divide it into trace 1.
Oh.
You're not putting the value. It will take.
It's minus 5.
What did you give here?
3.67.
3.67. Minus 5.
That's very cool. I like that.
But directly, you can plot many points.
Yeah, that saves time. Because usually you do analyze graph.
And minus 3 and what did you say?
Minus 3. No, minus 5.
Minus
comma
5.
3.67.
Here, this point here. And you can have more points also.
Yeah.
But anyway, this is your, what kind of discontinuity is this?
This is.
There are 2 kinds of discontinuity here.
The one with the hole.
Yes, there's a.
Infinite discontinuity. No, the second
there's
one.
There's an infinite is also there. Both are there.
Okay, you need it. I'm confused on that.
Now there's a hole at x is equal to
2.
So wherever the 2 is there.
Just draw a circle.
So now what kind of discontinuities are there? There are 2 discontinuities over here. There's an infinite discontinuity.
Yeah.
And there's a point discontinuity.
How does infinite discontinuity work?
Because it's going to infinity. The graph goes to infinity and then it comes back from down.
If it was minus, then there'd be no infinite discontinuity, right?
Whenever there's a vertical asymptote, generally there'll be a infinite discontinuity.
Just something to remember.
Yeah.
OneNote's cheeky.
Discontinuity. Yeah. See.
Very cheeky.
God, man.
What's happening?
I don't know.
Is that supposed to be there?
Discontinuity. So infinite discontinuity. Let me tell you that. Correct. And also there's a what kind of discontinuity?
Whole discontinuity.
Whole discontinuity. So point discontinuity. That's called point discontinuity when there's a hole.
Oh, okay. Whole, but point discontinuity.
Because
the
hole is a point where the function is
makes sense. Yeah. It's just
okay. I want you to try this on you. Okay. So first of all, there's no hole in the graph.
Yeah.
Why there's no hole in the graph?
Because I factored it out
and it's not possible to factorize. Yeah. So if you factorize it, if you remove 4 common, correct? So this is x plus 1. In my denominator is x minus 2, x plus 2. Correct. So there's nothing cancels out.
Right.
Okay. So how do you find out? So horizontal asymptote?
Yeah.
Y is equal to 0?
Mm-hmm.
Because it's like 0x square upon 1. 0 upon 1. You can think like that. So y is equal to 0. Vertical asymptote, make the denominator equal to 0. So you have x is equal to 2 or x is equal to minus 2.
Yeah. And the horizontal asymptote is 0 because when it's greater in the denominator, it's always 0.
Perfect.
And if it's greater in the numerator, it's undefined.
Perfect. The next thing is, how do you find out the x-intercept?
4x plus 4 is
Put y is equal to 0. Correct?
Yeah.
So 0 is equal to 4, x plus 1.
Yeah.
So x is equal to minus 1. How do you find the y-intercept?
You plug in x is 0.
X is 0.
So you get 4 upon minus 4, which is minus
4 upon y is equal to minus 1. So this is minus 1, 0, 0, minus 1. Again, this graph is very bad. Because it's very closely packed.
Yeah, I see that.
You know?
That's weird.
What does it matter?
Shreyok doesn't care.
Okay, and then you use your calculator and you graph it. And you take any points. Which are the points you took using the calculator?
Oh, I did not do that, but I'll do that.
Take any 2 points. Take any 2 points in all 3 regions.
Okay, so we'll do 4, 1.67.
4, 1.67.
Then we'll do minus, no, I can't
And
do
take any random. Don't take the asymptotes though.
minus 1.5.
Oh, why you're taking? Take far off, no.
No, because the
it's going
asymptote is minus 2 for this one.
Okay, but take something far off.
So minus 2 because that's the only point. Look, because for this graph there's a domain restriction.
That way. Oh,
Yeah.
okay. So take within that. Chalo, theek hai.
So 1.14
Minus 1.5.
minus 1.5.
If you take minus 1.8, what happens?
Yeah, I can also do that.
It will go a little higher. I just want a point.
4.21. Okay?
Correct.
And then we'll take minus 6, which is minus 0.625.
Yeah, okay, theek hai. What is it? Sorry?
Minus 6, comma, minus 0.625.
Okay.
Nice. This is all very easy if I'm honest.
Yeah.
It's just, I can't forget anything, but other than that.
But it's a long, cumbersome process.
Yeah.
Why?
But I like these types of questions, like.
Yeah. So
I find these.
So this is your horizontal support y is equal to 0.
Yeah.
Okay. X is equal to x is equal to minus 2. Then minus 1. This is so bad here. It's so close, no? Here.
Yeah.
And this is here.
Minus 1 and
this
0.
is and then 4 comma 1.67. 4 comma 1.67 is also so it's coming so close.
No.
Little higher.
Yeah.
Next to 2. Okay, here. So
Yeah.
and minus 1.8 and 4. Okay, ठीक है. You mark those points. And basically this is going like this, na?
Yeah.
This is going like this here, and it's not like this, actually. This should go towards it.
Yeah, it should come.
I'm not able to draw with the stylus properly.
Yeah.
I'm not being able to draw with the stylus properly, but it shouldn't look parallel to this.
Yeah. Looks good enough.
Yeah, good enough. Like that.
Very nice.
But you have to do all the processing first.
Yeah.
And then you will be able to draw the graph. Yeah.
But I know what to do.
So the Reynolds Metal Company manufactures aluminum cans in shape of a cylinder with a capacity of 500 cubic centimeters or half a liter. The top and bottom of a can, correct, are made. So this is showing open over here for some reason, I don't know. But they're saying top and bottom of a can are made of special aluminum alloy that costs 0.05 cents per square centimeter. The side of the can are made with a material that costs 0.02 cents per square centimeter. Correct? Find an expression for the cost of the material of the can as a function of the radius of the can. I'm assuming it's a closed can, even though the diagram is showing open, because the description and diagram doesn't match for some reason. So, what is the volume?
Pi r squared times h.
What is the volume given to be?
500, sorry.
Correct? Yeah, a function of radius. You want to get rid of height. So what will height be? 500 upon pi r square.
Yeah.
Fine?
Yes.
Now, the side.
Because I have that actually.
So, the surface area of the side is what?
2 pi r.
Okay. You really need patience with this thing, yeah?
What are you trying to draw?
I'm trying to draw.
No way still.
Just stopped randomly. Okay, fine, good. So let's continue. Now hope this writes. Okay, so the side is, listen, 2 pi RH.
Yeah.
2 pi RH. The top, we have to assume it's a closer. The top is pi r square. Correct? The bottom is pi r square. Now we are finding the cost. So this is the special alloy at the top and bottom cost 0.05 cents. So I'll multiply this by the cost 0.05. Yeah. I'll multiply this by the cost per, and I'll multiply this by the cost
0.02.
Correct? So therefore the total cost would be 0.04.
I was so close.
Pi, correct, RH.
Yeah.
Plus 0.05 and 0.05, 0.1.
Yes.
Pi r square. So therefore the cost will be 0.04 pi r. And what's your h now?
H is
500 upon pi r square.
Yeah.
Plus 0.1
pi r square.
Pi r square. So pi cancels. This and this will cancel. 5 4s are 20, correct?
Yeah.
So your cost would be 5 4s are 20. This two zeros, correct?
Yeah.
And that 2 decimal. So 20 basically.
20, yeah.
20 upon r.
Yes.
So I'm cancelling this. So basically 20 upon r, because if I take the eraser again, something will happen.
0.1
pi r square.
Yeah. That's your equation.
That's your cost.
Okay.
So least cost. So graph this on your calculator. 20 upon r.
Can I do 20 upon x?
20 upon x plus 0.1.
Yeah.
So you'll see a graph.
Yeah.
Just show me, I didn't see.
Wait, what is this standard?
No, standard won't show you.
Just zoom out there.
Zoom auto. Or zoom fit, something like that. Yeah. So you're getting something like this.
Yeah.
Correct? And then you find a minimum cost. So G solve minimum. Least cost we want.
Okay, so
Minimum.
How do I do that again? Is it this?
So what you need to do is you go to menu, menu, analyze graph 6, minimum 2. You take the left of it, left lower bound.
Right.
You know it is here.
Yeah, and it can be negative.
It can be negative, but here it's not negative because look. So 3.17.
Yeah.
So your minimum is
3.17.
Yeah, again this got stuck.
No.
I don't know what's happening here today. 3.17. See. 3.17, comma 9.47.
Yeah.
Correct? So that means your minimum radius, the minimum radius would be 3.17 and the minimum cost would be 9.47.
Yeah.